So here is one more example of a linear equation in one variable. We know that linear equation is an equation in which the variables represented by alphabets have the maximum power of one, and one variable, the equations in which one variable occurs, which is represented by alphabets, this equation in one variable. They are one of the easiest equations to solve. So we'll learn today with the example how to deal with such an equation. So today the question is solve for x. So in this equation, x variable will be represented by x. So the equation is x over 2 minus x over 3 plus x over 4 is equal to 2 minus x over 6 plus 5x over 12. So the general method or an approach to solve such equations is to collect the terms of x on one side. So we have many terms in x. All these terms are terms in x. So we can collect them on one side. So let's see what it means by collecting on one side. So we can see that this is minus and this is plus. So when these terms go to the other side of the is equal to sign, that is go toward the left hand side of the equal to sign, they change their sign. That is the minus terms get plus and the plus terms get minus. Addition becomes subtraction and the subtraction becomes addition. So let us see what happens when we'll write the terms of the left hand side as it is, like it is copying down. So we have copied down the left hand side terms, and now we'll write the x over 6 but with a plus sign. We'll change the sign. And similarly, we write 5x over 12 but with a minus sign. And what remains on the right hand side of the is equal to sign? Only 2. So we write it. So now what happens is we have to see the denominators and we have to take the LCM, that is the lowest common multiple. So the lowest common multiple of 2, 3, 4, 6, and 12 is, of course, 12. 12 is the lowest common multiple of these fractions. So we are going to collect the numerators under a common denominator, and common denominator will be LCM. So now look at this fraction, x over 2. Its denominator is not equal to the LCM. So it means we have to multiply its numerator by some number. Where will that number come from? Let us see. How will that number come? We will use LCM over denominator. We'll multiply the numerator by a number which is equal to LCM over denominator. So what is the LCM? 12. We'll divide 12 by 2 and we'll get 6. So we'll multiply x by 6. So we'll write 6 into x. Similarly, in the second fraction, let's see. Is the denominator equal to LCM? No. So we'll apply the same thing again. We'll divide 12 by the denominator, but denominator in this case is 3. So we'll divide 12 by 3 and we'll get 4. So we'll divide minus. Now the minus sign is copied as it is from here to here, and we'll write 4x. Where does the 4 come? 4 is the result of the LCM over denominator. Similarly, for the third fraction, the denominator is 4 and we should multiply the numerator by some number, and that number would be 12 over 4, that is 3. That is, we should multiply x by 3. Similarly, for the fourth fraction, which is x over 6, so we must multiply the numerator x by some number, and that is 2, because 6 2s are 12. Do we need to multiply 5x by any number? No, we don't, because its denominator is equal to the LCM, so we can write it as such. Right? So we have combined all the fractions, and we can see that all these are like terms, so we can add them. So when you add them, you can do by any method, but we normally do by adding the plus terms 6, 3, and 2. So that is 11x. Similarly, minus 4 and minus 5, minus 9x over 12 is equal to 2. And 11x minus 9x becomes 2x over 12 is equal to 2. And further on, it becomes, so now 12 is in the division. If something is in the division, it goes to the other side and gets multiplied. So 2x is equal to 2 into 12. So it becomes 2x is equal to 24. Now we have to isolate x completely one by one. 2 is in the multiplication, multiplied with x, it goes to the other side and gets divided with 24. So we do that. So x is equal to 24 divided by 2, that is 12. So our answer is x is equal to 12. You can check this answer by putting x is equal to 12 in the original equation, and you will be getting left hand side is equal to right hand side.